approver have agreed on a hike of salaries of employees of the company's new factory in Nitra after several months of collective bargaining. The unions and the company.
So this is just a video about repairing a Heathkit AR3 receiver. This is one of the receivers that I want to use in the novice part 2 presentation, which shows using some novice equipment on the air. But first we had to get the receiver into operating condition. So I got this little AR3 for $10, and I've done a little work already. I've cleaned up the top as best I can, and where it was terribly rusted, I hit it with some copper paint, some ordinary copper paint, you know, from the hardware store. I also hit the transformer with some flat black paint by just taping off the areas around it so I wasn't getting too much overspray. I did not go crazy. This is not a complete restoration. It's simply a cosmetic improvements. I can see right off I've got some problems. There's no dial string at all. I'm missing my pilot lights, and there's some things that are unwired on here. This capacitor, of course, is subject to test. It's probably going to be dry and have to be replaced. And I had a lot of problem with this vernier dial. I now have it freed up, but I had to hit that with a heat gun to free up the grease. It had completely solidified, and I put some penetrating oil in there and worked it, and now that is beginning to work. So this is the first step. I haven't really done much to it yet. It's just cosmetic. Similarly, on the front, I had a switch that was completely seized up. This one right here, you can see it's a little bit off color, and I've put some naval jelly on there to get all the rust off that I could, and again used penetrating oil in the heat gun to get it freed up, because I did not want to replace it. I wanted to try to refurbish it. So the front's looking a little better after a cleanup. Again, this is not a restoration as much as it's just reconditioning the set into a usable condition. So digging around in the junk box, I found a small PC cord that's thin. This is a 3-wire AC cord, and even though this radio seems to have a good cord on it, I like to have that extra ground. So I'm going to break the rules and put on a 3-wire grounded cord. Also in the junk I found 3 pilot lamp holders. Came out of something. I don't know. I threw it in the junk box. There they are. They're nice and shiny. And a couple of bulbs. They're not type 47s, but they're close. They're type 130s. I measured them at 6.3 volts, and they draw 150 mils, so they're equivalent to the 47s, and that's what I'm going to use in there. So a well-stocked junk box, and we can start to refurb the radio. So now the proper 3-wire cord is secured and tied in. So one of my engineering friend's dad, he was a radio repair guy, a real radio repair guy, and I got a stash of some of his leftover stuff. And one of the things I got was this radio dial oil and the dial string, the waxed or whatever dial string. I've held on to this a long time, and finally we have a patient, somebody that actually needs a new dial string. So some of you guys are going to get kind of religious on me on this dial string thing. You could use, with such a simple pattern, you could use fly line backing. You could probably use ice fishing Dacron. It doesn't have to be anything special for such a simple arrangement. And you'll notice I'm using a ballpoint pen spring. Pretty primitive. And it's working just fine with that ballpoint pen spring. So I just did some overhand knots and just touch the tag end with the soldering iron just to keep it from fraying, but who knows how long this will last, but it's a pretty heavy line. So here's an issue. As you can see, these substitute bulbs, they're not number 47s, which you just push into the grommet and they just stick out a little bit. They're pretty bulbulous compared to the 47, so I had to stick the sockets in, put the bayonet in, and then shove it back in as far as I could. We will see if this is adequate. I might have to go to the 47s if the bulbs stick out too far and the panel doesn't fit. So something I'm noticing on the radio is that just about every fastener, that is every screw and nut, is oxidized and loose. So you need to go through with a 1/4 inch nut driver and a flat blade screwdriver and loosen and retighten all of those fasteners. And if you have deoxit, not a bad idea to use some of that too. If I would have just turned this on and tried to reform the capacitor with all those loose screws, I would have been chasing ghosts for a long time. Okay, all of the wires that I took off during the repair process have been replaced. The speaker's been mounted. All of the fasteners have been loosened and retightened. Depending on fasteners, to get ground on a chassis is important. So now that we got the wiring back to normal, everything that I've disconnected I've soldered back. The speaker's now mounted. You would think, okay, time to fire it up. It really isn't. We need to check every single solder joint in this thing, and if you have to, add a little solder and reflow. So I'm ready to start reflowing all the solder joints that are going to need it. And I've got my fumes fan going. I've got my magnifying light all set up. Start soldering. Okay, step one. All tubes are out. The set is upside down. I've got my voltmeter ready. What we're going to do is we're simply going to see if the dial lights come up. Okay, we're all the way up. The lamps are on. Okay, all of the tubes are in the radio. The reason we want all the tubes in is we want to have the proper load on the high voltage. That capacitor is going to need to be formed if it comes up at all, if it doesn't have a short. Okay, so I'm attached to the first part of the filter capacitor, which connects directly to the rectifier. And I'm going to start bringing up the variac slowly. And look for that meter to move a little bit. Okay, the meter's beginning to move. And I would say the variac is at about 30 to 40%. It's starting to slow down now around 25 volts. So it's time to turn the juice up a little further. We'll go up to 50%. We're starting to hear a hum. This is the first noise we've had out of the radio. Just telling us that the audio amplifier is beginning to come alive. And notice that the voltage actually went down. That's because the tubes are now starting to have emission and draw current. Okay, we're at about 70%. And we're looking at 153 volts on the first cap. I would say that we're already kind of in trouble with the capacitor because it should be higher than that with 70%. Okay, we're at 80%. I'm going to put my finger on the antenna. Guess what? It's basically working. We just got a lot of hum. So actually I couldn't wait. I had to hook up an antenna to it.
Welcome to the English broadcast of Radio Slovakia International with your host Martina Šimkovičová and sound technician Tibor Bogdan.
So I have replaced the electrolytic capacitors. I actually use three 47 microfarad capacitors, so I've effectively doubled the capacitance of the original circuit. That's not going to hurt anything, it's just going to improve the filtering. And those capacitors happen to be handy and fairly common values. Remember to use 450 volt minimum electrolytics on the high voltage, and on the low voltage at least 35 volts.
Axis in particular that you had voted for.
You know, in every, I find...
Now, I have not touched this receiver as far as touching any tuned circuits or IF cans. This is just the way the receiver was. Let's go up to band B. We'll go up to where CHU should be at 3.3. That's pretty close, actually. Not bad at all. So let's try the BFO next. We definitely have a problem with the BFO. So we're going to have to do some troubleshooting. This is a reflexive circuit, which means the detector tube is operating as a detector, an audio amplifier, a BFO, and I believe a limiter, all at the same time. Yeah, something going on around that 12AV6. I changed the tube even, it's doing the same thing. Also, you might notice this is not the 12V6 audio output tube, it's a 12A6. They're essentially equivalent. Sometimes the 12A6 is an easier to find tube than the 12V6. So, I was able to calm down the BFO a little bit. Again, it's a grounding problem with those screws. They're depending on the screws of the tube sockets way too much to provide the ground in essential places in the circuit. You need to get solid ground on this receiver, and that means you're going to have to remove all the hardware, clean it, reassemble it, and make sure it's tight. Use some deoxit. Or reinforce the grounds by taking straps directly to the chassis and soldering, which I suggest. Especially around that BFO tube, we need to get a good solid ground. So we've got a couple of the tubes well grounded now. We have the IF tube and the detector BFO tube fairly well grounded. So let's take a look here. When we wiggle that tube, we hear just a little bit of static. We shouldn't hear any. If that socket was completely clean and it was well grounded, we wouldn't hear any static. Now that detector BFO tube is completely stable. Let's go to the mixer. Okay, here's the mixer. Oh yeah. Okay. Our job is not done yet. You need to be able to wiggle all of those tubes in their sockets and not hear a sound. That's when you know you've got your grounding right. That's when you know you have all your connections clean. And, you know, an oxidized receiver like this, you can't have enough good connections. Oh, the radio will work. It's just not going to work well.
.40 meters from Kilo 3 Lima Radio. Kilo 3 Lima Radio calling, looking for Canadians or other DX. From Kilo 3 London Radio, K3LR.
So the way we cleaned up the sideband was by adding some capacitance to the screen grid of the pentagrid converter in first IF, which regulated that so that we weren't getting the feedback and the hum modulation on the local oscillator. The radio really could use some regulation.
For Canadians or other DX from Kilo 3 London Radio C3
This is 40 meter single sideband, 40 meters. It is as it is, so the next step will be to take it through a full alignment. But 40 meters is a little bit tricky for CW. But it is working. We now have it working on all modes with a minimum of feedback. It's still fairly unstable mechanically, but once it's tuned up and in its case, I think it will be as designed from the factory, at least on 80 and 40. So my message to you is, if your radio is properly cleaned up, all the grounds are improved, capacitors are replaced that are leaky, you'll get pretty good performance, at least on AM. On CW, however, you may need to do some extra things like spread out some decoupling capacitors, improve the grounding by soldering some small wires straight to the chassis from those tube sockets. And it seems to stabilize the receiver for single sideband and for CW. So you can see this generator that I'm going to use to align the receiver. I tried to sell this for 15 bucks at the ham flea market, and people said it was so ugly and so old that I should just take it to the trash. A lot of stuff is left in the dumpster at those ham fests. But I figured, yeah, this $15 RF generator will be perfect to align the receiver. Why use a really high quality piece of equipment when you can use a classic? So step one is to make sure that the antenna trimmer is set at half of its range. So the plates are going to be half mesh. That's important because when we align it, we want to have some play in the antenna trimmer. If the antenna is too short or too long, that can make the difference. Also, set the knobs so that they correspond to the right angle of either the control or the switch. That'll make the alignment much easier. Okay, we're pretty sure we've got all the knobs set right. So I know that, oh, that one's not right. That should be AM, standby, CW. That guy's got to go a little further to the right. The next step with any alignment, that's correct. The next step is to let it warm up. So on our primitive generator, it looks like it's reading about 457 kilohertz, but on the frequency counter it says 455, so close enough, 455. If you're off a couple kilohertz, it's not going to make any difference. As long as the IF transformers will tune, that's fine. So we're just doing a check to see that we're around 455 kilohertz. We're also going to need to have some modulation. So on this advanced piece of test equipment, we have a 400 cycle. So we're going to put a tone on this thing. We're going to put it in AM. We're going to give it a 400 cycle frequency. Okay, so we have the generator set for 455 kilohertz. And we've got 400 cycles of modulation on. We start by tuning the bottom IF of the IF can slug and then the top, and repeat for both of them. This is called the straight-through method. The straight-through method means you take the output of the generator directly into the input of the receiver, blasting through the mixer stage and pretending it's not there. We're on the highest frequency and we've got it set for 30 megahertz. So we're going straight through with 455 through all the stages, and we're going to tune the back end by injecting into the front end. Okay, I found the appropriate tool. It's a plastic tuning tool, but it has a metal, brass, flat head on it. This is going to be what's needed. So we're going to need to turn it over to tune the bottom IF transformer first. Next, we want the band spread control fully meshed, and we're going to leave it in this position for the remainder of the alignment. Next, we want to set the receiver to the highest band, band D. That's all the way to the right. And we want to tune the frequency to 30 megahertz. That's going to be our first adjustment. Note that I'm connected directly to the generator's 50 ohm output. We're tuning this ideally through a 50 ohm attenuator of 6 dB because most of the time we're using a 50 ohm antenna. Originally the receiver was probably made for a random wire, but we're going to tune it pretending we're using a 50 ohm antenna. So this first adjustment is interesting because it's setting the 30 megahertz portion of the band, and there's nothing you can do up here that makes any difference. It's all about this first trimmer right here, and it is touchy. Right now it's about 31.5. It's not that far off. It's pretty nasty. Okay, so we now have .30 megahertz adjusted. Next we will look for the image frequency, which is twice the IF plus the frequency, or 30.9, and see if we can hear the image. A simple receiver like this will have an image, so at 30.910 approximately we should see it. Okay, there's the 30. Now we're going to go up. And there's the image. The main frequency, 30 megahertz. And the image. It's down a little bit. You can't expect a simple receiver with only a mixer and one tune circuit to have good image rejection. So next we go from band D to band C, and we're going to be tuning up here for band C. Our next set point is in band C, 4 megahertz, and we're tuning the back. Okay, for a peak. Okay. Now we adjust the front. For maximum output. And again, this is with the band spread fully meshed. Next we tune to 10 megahertz. Put the generator on 10 megahertz, and we're going to be adjusting the capacitor this time. Okay, 10 megahertz is set up. Seems to agree with the antenna trimmer as well. Okay, we're tuning the generator for 1.5, and we're tuning to 1.5. Just for fun, let's see where it is. To 1.55, so it's just a little ways off. So let's adjust that back to 1.5. Okay. Now we're at 4 megs. It looks like it's a little low. So we go back to 4 megs on the generator. And then we're going to adjust the trimmer to bring it up a little bit. And then finally touch up the front. Again, the trimmer's excellent. Now we're going down to band A, 0.55, and the generator's reading 0.57. So we've got to go up in frequency. It's high, so the slug has to go down. Okay, 550, 1500. We're reading around 1400, so at 1500 we need to come up in frequency. So this needs to come up. Finally, we should set the BFO. So we turn the modulation off on the generator, set it for 455 kilohertz, and then we just go for 0 beat on the BFO coil. That's it. Done. BFO set. So the way to use the band spread is you tune to the bottom part of the band, for instance 7.0 if you want to cover 40 meters. So the radio is picking up WWV both on 5 and 10 megahertz on band C. So we're looking at the Heathkit AR3 after some restoration work. Not all the knobs are there. Looks like I have exactly one. The middle knob might be considered somewhat original looking, but the rest of them are some knobs I grabbed off an old Heathkit oscilloscope, and the tuning knob, of course, is a large DAC-aware knob. The red pointer on the band spread is the tip of a Bic pen cover. It makes a nice little pointer for the band spread. Fairly stable after about a half-hour warm-up on lower bands at least. Band D, you got to wait a little longer. Bit of hum modulation on CW, but certainly usable on 80 meters for a novice receiver. So we've got some more equipment to get operational before we do the novice part 2. I have a Heathkit HR10 that needs to be brought back to operating condition.